I'm Daniel Bryars, and I'm doing a little talk on what I do differently now. So yeah, a bit of background about me. So I couldn't believe it when I added it up, programming for about 37 years. And my first computer was a BBCB, an Acorn BBCB bought back in 1984 when I was 8. So that's quite a while ago. And I started programming in BBC Basic, typing out games and magazines, where you used to get the magazine and then type them in and then play the game. It was a lot of fun. I'm an engineer. I'm not a computer science major, so my experience has been really sort of the applied side of software programming. And professionally, I'm mostly on the systems programming side of things. So I started out doing C programming, embedded systems, and I've got experience with old school Visual Basic and Delphi for controlling these systems. And then more recently, which I mean this century, starting in C#. So I remember when C# 2 came out and generics were introduced, and that was awesome. So, which didn't seem that long ago, but was 20 years ago. So and now I'm a technical director at a company called Speak. We're based in Oxford, and we are hiring. So if anybody wants to talk to Curriculo, please, if you're looking for something, please reach out to those guys. They're great. But I still keep my hand in writing code. And as Dan said earlier on, the changes that are in .NET Core and C#8 and so on and so forth are really, really good. And the pace at which they're developing and carrying on with the language is awesome. It's keeping me really interested. It's great. So what I wanted to talk about a little bit was just about some of the mistakes or some of the things which I look back on and I think, I wish I'd done it differently. And it's worth bearing a bit of context in mind. There's changes in technology. So the technology has changed. So you can do things more easily in C# now that you couldn't do back. So, C# 1 didn't even have generics. And then, of course, there's experience that comes in, which changes the way that you look at stuff. And also, for me personally, when I was first writing code, it was in a very small team. And now I work with a larger team, with a bigger company. And that's different. So you have different challenges, and you need to change your coding style, or different coding styles suit working in a team better. And that kind of comes into maintenance. And it's one of these things where some of the stuff you write lasts a long time, and you look back and think, why did I do it that way? So I just wanted to share some of the stuff which I thought, why did I do it that way? And a lot of it is probably obvious to you. It certainly wasn't to me at the time, or I didn't see what problems it would have. I think one of the fond memories of a mistake that I made, one of my early jobs was I was working for a manufacturing company, and they had an ERP system that's an electronic resource planning system, an old database, IBM database called Unidata. And I mean, this thing is old, so it's from the 60s. And you could, it would essentially schedule work throughout a factory. So jobs lists and things to do and what job was coming up next and all that kind of stuff. And I was writing a report for it. And so, in fact, it was early 2000s, it was in C# or maybe Visual Basic, I'm not sure. And I was writing a report, doing some bits and pieces. And the guys in the development department decided to pop out for lunch. And we came back, and the whole of the production line had shut down. Nothing was working. Everything was dead. I remember thinking, oh, well, looked into things, and people were saying, oh, the database is down. It's the problem with the database. I was only running a report or playing around with some reporting, wonder what's going on. And I'd left a piece of code with a debug breakpoint on it, and popped that for lunch, had a couple of sandwiches, got back again, and that had escalated into a full table lock, which had stopped everything from updating the database. And I just hit F5, database sprang into life, and there we go. The production line was going on again. So that was I kind of got away with it, but something which you might not expect is debugging on production systems. Probably not something that you should be doing. One of my first applications, there was a book from Rocky Lockter, and really good book, excellent book. But the way, and I think this has moved, Dan mentioned again, as we move to more functional programming paradigms, we're sort of moving away from some of the older object-orientated styles of programming. And Visual Basic.NET Business Objects is something that I'd used quite a lot when I was younger. And for this, you'd have a business-based object, and it knew how to write data back to the database. It would know it would expose stuff for the UI in the same object. It would have serialization in the same object, and you'd inherit from business base, and you'd override what you'd need to do. And then the customer could save itself, could update its properties, and notify when things changed. It sort of seemed like a nice way to encapsulate an object in a sort of a business object, customer or an account or something like this. And I've learned that that's quite painful to deal with. So most of the time when I'm writing code, I kind of look and think, gosh, I wish I'd separated the state into an object on its own that just had the state in it. So the new C# records are ideal for that. And I'd wish I'd separate how to serialize the object into another object, which didn't have any state. And how do I store stuff in the database is a different concern. So not mixing state and behavior is something that I do now, not religiously, but I tend to find that it's very, very useful. So I'll end up writing a separate class which represents the data over the wire, and a separate class that represents, and usually immutable classes that represent a state somewhere else. And then you can use object mappers to map between them and so on and so forth. But it seems like more work, but it turns out to be much easier and less brittle. This is a sort of an example where I'd have a customer, it has a name, there's a date time offset for the date of birth, and I'll have a completely separate class, which is a serializer. And you might be drawn into maybe writing a toString and a customer that serializes it or something like that. And that's it's better, or I find it better, to have a different class which has got its own single responsibility for just doing that serialization. And same with customer database access. I'd just have a constructor on customer, which would then let you load from the database. But now I tend to do this, and that's better. And I wish I'd done this more before. The other thing, just talking about serialization, is that every time you use binary serialization, a rabbit dies, and it's a cute bunny rabbit that dies. It's an awful thing. I used to use binary serialization all the time. I thought it was great. It was really, really easy. And going back to the separate concerns, I tend to now try and have an object that represents the state of what I'm trying to serialize, and then have a separate thing that serializes that state. And the thing that I want to serialize is really all to do with the state of serialization. And the trouble I got myself into with binary serialization is I'd end up serializing an entire object graph where I didn't need all of the things. And you chase down pointers to event handlers, and I remember all sorts of nonsense like that, which is a bit of a nightmare. The other problem with binary serialization is that and it doesn't save you any more time. It seems really easy. I'll just serialize the state of this object graph and then I'll deserialize it. But what happens is later on is you might move types around, change your namespaces, move them in assemblies, and then you can't actually, when you change those, the binary serialization breaks. You can't read what's being serialized. It's very, very difficult. So it's very difficult to debug what's going on. And there's been a few times where I wanted to have to change what's happened. So if I serialize some state into a database, I might want to go and update something in that database. And now I can't do it. So binary serialization has definitely bitten me, and I wouldn't do that again. One of the other things that I thought was the future was SOAP and WSDL and in web services, and also Silverlight too, but I'm going to keep that secret. I don't tell anybody about that one. But yeah, so I thought SOAP was the future, and yeah, it turns out that it wasn't the future. And the reason why it wasn't the future is because it's just too complicated. I mean, the idea is good and it's defendable, but it's horrific. I've read these books, and you kind of assume that it must be the right way because there's these big books and there's these things that tell you they solve all these problems. But life's too short to read a book for 800 pages on just designing and versioning the contracts for web services, the WSDL. And I've found that complicated things, they try to do all of the development up front and solve all of the problems. So transactions over service boundaries, I thought was a really good idea. I thought, oh, if I've got multiple services, I want this to happen all into one atomic unit. But now I'll tend to keep it much simpler and not get into all of that and try and make things idempotent. So you can just call that service and then call that service or do something else. And the complexity of having some of these things just wasn't worth it. And I think that's why it failed. XML's horrible. The encoding is terrible. Whether or not you've got an encoding at the top of the XML file, you can debug it for hours and try to put it into a database and schemas and so on and so forth. So going with simpler things like JSON it's just much, much easier, and it does the job. It does everything that you need 99% of the time. So yeah, that's something I've learned. Yeah, I wrote a lot of frameworks, and I thought this would help me and people. And the frameworks I would write would solve too many problems. I've got a little example of this in a minute. And they were brittle, so you'd always want to use it in a different way than was quite imagined. So you'd always have to keep extending the framework or provide points for modification in that framework, which meant that the framework becomes very, very complicated very, very quickly, and it's no longer solving the thing that you originally imagined, and it gets very, very complicated. So I wish I wrote smaller libraries and then compose those libraries. So yeah, so this is an example of a framework, some sort of Acme service. All of our services at the company Acme are going to do this. They're going to set up logging in the same way, set up more stuff the same way, and then you're going to do your service. You're going to have some sort of abstract method here. And then when you want to implement a MyA service, which is an Acme service, the idea is you've got a company standard that you need to be doing. Then all you need to do is override the method, do your service, and everything gets set up for you. But in practice, this is really bad. people want to do things differently. They want to set up logging differently. You want to set up more stuff. You have to keep adding more abstract pre-setup logging, post-setup logging, pre-setup more stuff, overrides, and it's troublesome. So instead, what I tend to do is have an Acme logging configurator or an Acme more stuff configurator. So these are libraries and they're opinionated. And this is what you need to do to set up logging the Acme way, or this is what you need to do to set up more stuff the Acme way. But then it's up to you to compose that yourself in your service. And the service isn't imposed. We don't impose a framework on the service. The service can opt into those kind of things. And then by having examples and code reviews, we can provide the benefits of the framework in terms of consistent code and doing the things, but without the troublesome complexity that arises for dealing with all sorts of different services that you might not have got in mind from the framework. And that's similar to how .NET Core, I think, is going in terms of the composing the components and the idea that you can pay for what you use as you use it. And it goes hand in hand with those ideas. Yeah, I wish I'd done it more like this. So, yeah. And I always wish I wrote a unit test for that. So I've never been religious about unit testing, doing many unit tests, but they are very, very useful. And I always look back and think, oh, I wish I'd wrote a unit test for that, because then I'll know how it used to work or something like that. And yeah, it really, I do like unit testing. So it means your behavior is really documented. That's really important, because I can't remember what I did yesterday, never mind 3 years ago. So it really bakes into that code. And that's really important when others are working on the code as well. They can see what you meant and you're documenting your assumptions in there. And also, you can change the code more easily, because when you're rapidly developing code at the beginning of the project, then unit tests are can add a little bit of impedance to things. And but when the code gets a little bit older, then it speeds it up having unit tests, because you can more readily refactor and know that your code does what it should be doing. And learning how to unit test is important. So if your unit tests are really brittle, then you're probably not writing the unit tests as well as you could be. And I find that writing unit tests makes me write better code. So I understand my implicit dependencies a lot better, like time. I could never use datetime.now because it's I always inject it in either through a scheduler or through just our own interface that we use, and things like that, which my last slide kind of explained there, where you're paying for a little bit more upfront complexity, but it's better longer term. And I hate static skyhooks for logging and skyhooks for things now on dependency injection all the way. And unit testing leads to dependency injection, which is great once you get used to it. And Ncrunch is obviously awesome. It's been around for quite a long time. But yeah, that's ACE, which runs all your tests in the background simultaneously. It's pretty cool. So yeah, and I guess the other thing is that I've learned is don't spend too much time on diagrams. You spend lots and lots of time drawing diagrams and making them look pretty, and then putting them into documentation. But what it ends up doing is that you document your code less. You just can't be bothered to write a README, and well, I can't, and do all of that and make diagrams pretty. And well, choosing a diagram tool is difficult enough. I go through different ones, and instead, I just take a picture of my notes. I'm going to show you pictures and notes I've got, and I'll just throw it up into Confluence. And yeah, you can rewrite it if you need to show it to a customer or something else. But going back to that diagram that you've had before is really, really useful. And just taking a picture of a sketch that you've got in your notebook and just throwing that up is in my experience really, really good. And then, yeah, so here's one. And we've got a graph here. We've got features going up across to the right, and we've got code complexity on the y-axis. That is sort of what's pain. And with something like dependency injection, you pay a higher price at the beginning, and especially as a junior developer, you think, why do I need all this stuff? You know, and if you've only got one feature or two, then it just doesn't matter. You're better off being down here. Don't use dependency injection. Just throw it up right direct to the console. Don't, you know, it's all good. But the initial cost of the DI framework is higher, but it pays dividends because the relationship between the complexity and the features is more of a linear relationship, which is great as you get more complicated and you do other things. But if you don't use these frameworks and these techniques, then as you add more features and new things, then the complexity is asymptotic, and you is bad, and you end up having to either reinvent the wheel or do these things anyway. That is the that's just a few things that I have come across as I've been developing for quite a while. But these are the painful things that are sort of top of my list, really, that I'll go back and think, yeah, I'll do that differently. So Dan, yeah, that's the end of my presentation. Thank you.
Awesome. I still can't believe you read all the SOA books. You read those to see it.
I had so many of them, and in fact, I've got one. I don't know. Can you see it? I've got it here, right? And it's just like, yeah, it's terrible. But yeah, I'm digging through some of my old books, and I've got rid of most of them. But yeah, nobody needs to read 800 pages of not when you can just use JSON.NET and serialize it out and fire it for a while.